Good evening. It is a pleasure to introduce tonight's guest, since he needs little introduction. Prolific author, architect, curator, industrial designer, publicist, professor, he is without a doubt among the most seminal figures in the field today. But in reflecting upon his work, a number of different comparative analyses suggested themselves, which fortuitously for all of us, I will only touch upon very briefly. Unlike Expressionism and Art Nouveau, just to name two possible affiliations, it is widely understood that the essential implication of Greg Lynn's project is that architectural form, in order to proceed, must begin to assume the properties of the formless, drawing from Deleuze, the fold, the multiplicitous, and the Baroque. Everything that fluctuates. Form is diffused according to phenomena that normally exert forces on it, such as air and water. But whereas the Baroque had a canonical form to distort, the classical canon, an orthogonal static framework, and infused it with dynamism, with Greg, the dialectical architect is asked to step off into a vertiginous freefall, precipitous in so many ways, not least of which is its effect on the relationships of parts to whole, which now dissolve in intricacy, a whole new model in which either there is no movement or there is no stasis because there is no detail, since detail, in his theory of intricacy, as he puts it, is everywhere and is constitutive of a coherent totality that appears to be inscrutable, even though for him it must be intensively rational at its basis. Though the production of intricacy is not an easy task, involving rigorous computation and fabrication, the rewards of its effects for the architect are virtually euphoric. His ceaseless morphogenesis is severed by definition from classical models of coherence and imitation, and because of this, he has managed to open an aporetic space at the very heart of the contemporary architectural production and discourse. As is already obvious, his ties to the Baroque are elusive at best, and though there is a vague evocation of such movements as Art Nouveau, Expressionism, and the one-man movement called Gaudi, no such connections are easily justified. Then, if we try to make an even further stretch to high modernist ideas of movement, we hit another impasse. Recall Corbusier, who made buildings that can be seen to be akin to ships out of water. This transposition in Corbusier's work caused a radical transformation of the basic elements of the architectural object, its relationship to the ground, and gave rise to an architecture conditioned by movement, but not in form that represents movement, and a promenade for a new peripatetic subject. Greg Lynn, on the other hand, leaves behind the surrealistic technique of transposition and instead deals with the water itself and all the forces that act on such things as boats. His source for the idea of movement in architecture has nothing to do with architecture anymore. It's movement itself, and this is where the most radical contribution lies. And so it is not surprising then that this moves him outside of architecture altogether in certain moments. For example, into the design of beautiful instruments at scales other than architectural, dealing with uses that are inseparable from his aesthetic of undecidable movement. We cannot tell yet whether he is bringing us to the end of movement in architecture as we know it, or if this is the beginning of a new modality which brings the thesis of motion to a higher level. His is a transgression of conventions that is so extreme that despite superficial iconographic associations that shine through his forms, and he welcomes those sometimes, it's difficult to imagine his work as transgression. And no matter how much he refers to it as the fold or the blob, and he doesn't do that now, but anyway, the project cannot be reduced to any of those things, nor can it be reduced to expressionist or organicist models. Its thematization of movement makes it impossible to pin it down under any rubric. Okay, last point. There is the lineage from Eisman that seems to be unmistakable, yet the gap between them is formidable too. Architectural autonomy is to Peter what the digital is to Lynn. If autonomy is a theory, the digital is theory as technicality. And herein lies the profound distinction between them, since technical mutation, the computer, is arguably at the root of the transformation of contemporary practice, and autonomy, it would appear, may not be. Greg Lynn, in fact, is the first to theorize the questions opened by this condition. No one in my generation can stake a claim of this impact. Indeed, he has engaged more continuously than anyone in the digital medium in architecture, and we will have to deal with him whenever we ask questions about this problem. Last and not least, we look at the fold, the blob, the animate, intricacy. We find in Greg an author of ideas. Though the blob has become the inevitable association that defines him, what's unique is that he is not only the author, the signature, nor merely associated with an oeuvre, but actually with a whole tendency. Please join me in welcoming Greg Lynn.
All right, thanks for coming, everybody. I'm going to go now. I'll just show a few slides. Well, it's really good to be here. You're catching me at a very odd time, and I just thought I would kind of get it out of the way. But if we can dim the lights, I'll go through. I pulled together things that are pretty much current and connected preoccupations that fall into these categories. I think the only thing that's worth mentioning up front is that the first preoccupation is robots, the last is media. I would just say that in my mind, there's been a lot of innovation in terms of architecture connecting with popular culture through the integration of media into buildings. I mean, starting with Venturi and now continuing to, all of the instances of digital facades and the integration of digital content into architecture. And that's what I'm going to end with. I think the robot issue is a much more exciting one, and it's something that's kind of been in the back of my mind. It's been something I wanted to put on hold with animate form because I didn't want the issue of movement to be reduced to literal movement in architecture. But nonetheless, if you go to Las Vegas, what you see is Las Vegas is now filled with robots. Where they would have had digital facades, they now have, deaccessioned automobile robots with people on trapeze flying through waterfalls. They have animatronics. I think literal movement is the new limit, let's say, for architecture. Okay, so, and in that vein, and I also think that, when you see the Transformers movie in a few months, you'll see these things are buildings. I mean, what's amazing about the Transformer film that's coming out is there are these things with kids in them moving around at the scale of suburban houses. It's like shopping malls running around, tumbling through the suburbs. And I think you just can't help but imagine what a literal movement in architecture is like. So now the reason I say that you've caught me at an odd time, and if we could just start the first little film clip, is that I've been collaborating with Frank Gehry and Peter Arnell for the last year on a project for a tropical family resort in Singapore with a casino at its core. And what's been incredible about the project is the similarities and differences between all the parties, but really it's been Peter Arnell who brought to the table the mandate that we had to synthesize pop culture and all of the things that Disney World did 50 years ago into architecture, so that the architecture is part of the entertainment, that the interior of the complex, its massing, its relationship to the city, that it needs to all be one organic whole. And I think this move into pop culture is one of the most exciting things I've ever been involved with. I would just say that, for me, I've always been a person that's been much more attracted to contemporary music, film, design, toys, all that stuff, and B films than I have been to high culture, to the arts proper, which is not to take away from friends and colleagues in sculpture and painting and video art, but it's the pop culture thing is really what makes me tick at a certain level. So I know it's a little deadly to start with a film, but what I want to do, if you can stop this one and start the next one, I'm just going to play a video that we did and actually hold on one second to hit play. This is a video we did. We're competing against 3 other developers to get this family resort complex in Singapore. And I'll cut it up because it's 7 minutes long, but I'll let you watch the first little bit. But the thing that I think is really great is, A, how we were looking to Asia for ideas. So rather than exporting Western development to Asia, we really were trying to go to Asia, which is driving pop culture in the most profound way possible, and pull from Asia a new paradigm for imagery and entertainment. And one of the ways we did that is with literal robotics at every scale. So from little toy robots that you can buy in the gift shop, to robots that are swimming around with fish, to robots that are climbing around in a botanical garden, all the way to the scale of the architecture, which is full of movement and robotics. We tried to bring it together, and we did it with Rod Brooks from across the street from you guys at MIT. So anyway, I'm going to just let you watch the movie for a minute. We'll get it out of the way. And I hear if we win this thing tomorrow night at 2 in the morning or something, so I just kind of want to get it off my chest. So.
I was reluctant for this project. I worried a lot about it and thinking and fantasizing what you could do that would be different. Once I accepted it, then I was determined, damn determined, to make it extraordinary.
Our idea for Singapore, for Sentosa, is create Atlantis, perhaps in the year 3000 as you would discover it.
The driving force behind the project was originality, to really push the boundaries, not to do something that was just an incremental improvement on what Atlantis is in the Bahamas or in Dubai, but to do something that was transformational.
I believe this is the first building that integrates the media and the experience of the building to make an iconic architecture that's fused with the media. It is a very cutting-edge place.
It seemed like somewhere there was some extraordinary connectivity between the fascination of the seas and the mythology called Atlantis. We started to look at fish life, we started to look at pop culture, we started to look at influences from all over the territory to see where and how in the future an experience could be built.
It's not an architecture that's passive, it's an architecture that's alive.
The ocean is pretty amazing. The result of which we felt, well, bring the ocean into the resort.
We've really packed this with incredible exhibitions and interactivity and storytelling that has never been done before.
I know as a father, my kids are constantly teaching me things about new technologies, and they're learning it all through entertainment.
So we decided that we would embody all those thoughts. We would create something called the aquasphere, the next generation of experiencing the aquarium as we know it today, aligned with aquariums of the future.
You'll have a building that's performing constantly.
We're going to have reality, we're going to have fantasy. I think it's going to be very difficult at the end of the day to distinguish between one and the other.
There's going to be living creatures integrated with robotic creatures, integrated with virtual creatures, which you maybe can't even name. Unlike theme parks, a visitor to the Robotanical Garden is going to have a unique experience. Every time they go there, things are going to be different because of the other people around. The robots will be responding to that person, to the other people. All people are different, and so the response from the robots will be different.
Okay. Well, you get the idea. I don't want to burden you with watching a film. I think the other thing about this project which is significant is, one of my best friends happens to run a movie title business that does, they're basically good at taking a 2-hour film and getting you in the first 3 minutes into the theater and into the story. And it's a company called Imaginary Forces. And when we started this, literally the first week, I said, look, we need to get Imaginary Forces built into this thing to not only document the process, but also give us feedback on every single one of our meetings and all the stuff we were doing. So films like this were cut, I would say, 2 a week for over a year. So there's literally hundreds of these films where they were giving back to us the story of the place. So we could start to develop the content, start to visualize the spirit of the place. And I think this is more and more common. I think Imaginary Forces used to do movie titles. KPF hired them to do all the digital content for 745 7th Avenue. And they did all that content for Morgan Stanley. And now they're kind of, one of a few companies that does the content for these digital facades. But they're really good at storytelling. So anyway, you guys laughed, I think, at all the right places, because this is for the ministers in Singapore to buy off on. So it's really a little bit of a, it's a sales tool, but actually it's a storytelling tool. And I think, architecture's engagement with new forms of media and also, this kind of content is very prescient. Okay, so if we can go back to the PowerPoint. Okay, so the issue of the robots honestly came about just because, for a long time my office was growing with just machines. Like, as a matter of fact, we were getting rid of people and getting more and more machines. One of the great things is, like, in my office, if you need like an X-Acto knife or something, nobody knows where they are. Everybody that does models, they just glue. Like, you ask somebody to change something and they go over to a computer and type something in and send it to a laser cutter and they come back, when I would just take a piece of scissors and cut something. But so, maybe 7 years ago, I got this CNC mill in the office for a specific project I did with the painter Fabian Marcaccio. we got a laser cutter in the office and we have a 3D printer in the office, and between these things, you know, everybody spends a lot of time fabricating things, and going from a design realm where we're designing surfaces and volumes on a computer and translating those things into a language that will be understood by a robotic machine. Because of that, real early on, I became a kind of mechanic for artists. And this is this Predator that I did with Fabian Marcaccio, which is a self-supporting, it's a little over 100-foot long, painted, sculpted plastic volume. And to do this, we really kept our roles very clear, that, you know, I was going to be dealing with the architecture of standing this skin up and fabricating it. Fabian was going to be the painter who was working with the areas of the surface that were painted. And to do it, we had to use digital means. And what was interesting is it was the digital construction technology rather than the imaging technology that was the common ground for us. So I was trying to work out how to take one of Fabian's paintings, like this, you know, 120-foot long painting, divide it up into pieces, print each one of those pieces digitally on a 4-foot by 8-foot sheet of plastic, form those sheets of plastic and assemble them so you'd get image continuity. At the same time, you know, we were thinking about how you put windows in a curved surface and how you bring all these things together. So you know, Fabian's desire to do an environmental painting and my desire to look at panelization and fenestration and surfaces, you know, brought us together where we could both work within our own realm of expertise, and it provoked a lot of fundamentally architectural questions for me. First, I mean, the obvious one that I was thinking about was just apertures. But what it led to, which I hadn't thought about, is texture and pattern. So all of these computer-enhanced modes that architects are working in, whether it's in design, manufacturing, documentation, model building, they all, for me, have to start from the idea that we're working in a new design medium. That this isn't just taking a tool and changing the way we do things, but it's actually thinking about the medium in a completely new way, and the medium has different characteristics than the previous medium had. And what I'll do tonight is just run through all the characteristics of this design medium. You know, initially, I'd have to say what I focused on was kind of ornament. And I think that the decorative qualities of CNC fabricated surfaces are getting a little exhausted at this point. At least in my mind, they're getting a little bit exhausted. But in these projects, this is an interior in Stockholm, Sweden that we did. And I think here, you guys at Harvard, you people at Harvard all know about the issues here, but we, you know, basically can work with anybody that's got automobile company, like any country. So we were in Stockholm, we knew they had Volvo and Saab. We called some designers we knew, we got to the people that build their car prototypes, and we basically did 2 sets of documents. One set of documents for the people that built the plaster walls and built the floor, another set of documents for the people that built the walls. The carpenters got a set of documents which were plans and sections. The automobile fabricators got, or prototypers, got tool paths, or, you know, G-code, which is basically turning the surface geometry into the pattern of a cutting tool. And what I'd realized from the Predator project with Fabian is that by designing the path of the tool, kind of for free, we could get this ornamental texture. And we wanted to integrate all of the shelving into the surface, and one way we could make these things go away was by putting this pattern over them. So the ornamental textural quality was something that came out of us producing the code for that wall. Similarly, this wall at the NAI in Rotterdam. But so the first kind of revelation on my part was that using these CNC tools and intervening in the process of sending a shape to a machine, you could get all of this patterning and decoration for free. One of the things that I started to try to do was get the pattern to be intrinsic to the form. And so this is a kind of tropical dart frog paradigm where as the frog changes its shape, the ornament and pattern changes with the geometry of the frog. So instead of applying these patterns, we started to try to grow the patterns off the surfaces. So where you would get more undulation, you would get more pattern. So these are some of the studies how we took surfaces. We located three-dimensional pattern generators, basically, things that would undulate the surface, so that where you got smooth gradients, you would get less pattern, and where you got tighter folds, you would get more pattern. So I think that's one issue for this new medium, is thinking about the craft of construction using digital tools. The second thing that's, I think, more profound about it is just that there's a notion of mass production and construction, which in my mind, it's a kind of a rule that if you're advancing something, you're almost always either reducing the number of parts, reducing the number of steps in the process, eliminating redundancy. You know, very rarely does somebody come along and say, I've got this great idea where I can make something much more complicated with more pieces. It'll take twice as long with more material. It just doesn't sound right. And a few years ago, Greg Foley from Visionaire magazine asked me to do a project with Hedi Slimane from Dior Homme. And, you know, he was just starting, but he was a super minimalist person. I think Greg Foley was being very ironic putting us together. We had a meeting, and Hedi said, you can do anything you want, but it has to be cool gray number 4. It has to be a box, and there can be no visible attachments, clasps, or hinges in the box. So what I did was basically take that block and figure out how to make a box that would open and close using a logic of surfaces. So it's a case for a magazine. So these ridges are what the magazine rides on, and the ripples along the edges are what keeps the case closed, and you can only open it if you lift it up perfectly vertically. If you move it side to side, these teeth bite together and it locks. So using the shapes and the intricacy of the surfaces, we could do what a hinge would do, or do what a clasp would do, and still produce this kind of minimalism. And so for me, this is you know, a minimalist direction for me. And now this, I'll show you a bunch of product stuff. But this is a set of cups for Alessi. But what I tried to do here was eliminate the handle and the saucer. So instead of having a cup with a handle that sits on a saucer, these are hollow. So the hot liquid sits in a volume, and then there's a hollow plenum, and then there's this outer surface. So what would have been the cup that you would hold on to becomes these bulges. So they're very ergonomically designed, I mean, for gripping them. But there's no need for a handle because you don't burn your hand when you grab the outside of them. So it's taking away one component and integrating it into a surface. And again, the pattern and undulation accentuates the curvature, makes it more voluptuous and sexy, which I think is just a principle of this kind of a pattern. It's why I went there originally, is curved surfaces look better with these kinds of patterns on them because you read the curvature. Okay, so also they can assemble, so they nest. So, you know, it's like these things are spooning together in different patterns. And that means you can set them up in all kinds of arrays where they interlock. In the same way that we got rid of the handles for this chair for Vitra, I wanted to take the notion of a bucket chair, like Saarinen and Bertoya's bucket chair, where you integrate the arms and the back and the seat all into one surface, and do the same thing with the legs, so that the whole chair is constructed out of two surfaces. Hence, it's called the ravioli chair, because it's also a square in plan that's made out of a soft top and a hard bottom, and you can assemble them modularly like a sectional into love seats, and you'll see some of them. So these were all the prototypes we did in the office. We did like a dozen of them. First we scaled them for my daughter, so we did kind of 2/3 scale chairs and tested them, and then we scaled them up. But it could let us really work out the kind of comfort and ergonomics. These are the ottomans and the side tables. And that's how they assemble together in this kind of sectional logic. So they have the shared parting seams are common, so you can attach these things together. And then the whole impetus for this came about from the fact that Vitra, almost all their contract furniture now, the upholstery is knitted rather than sewn. So like a task chair, the back of it is like a sock, and it's knitted with a 3-dimensional knitting machine and pulled over and connected with a drawstring rather than built out of sheets that are sewn. So the contours, like across the arm of the chair, there's 2.5 times as many knots as there is across the front of the chair. So we designed a 3-dimensionally knitted top that fits snugly onto the seat, and because it was robotically knitted, we designed every pattern so it would be different. And I just think this is it was a shocker to me. We presented that to Vitra, and Rolf said, oh, well, you've managed to like make my nightmare, because our worst problem at Vitra is pony skin, because obviously every pony is different. So they'll put a picture of a pony skin Corb chaise in their catalog. It'll have a big brown dot and 2 small black dots. Somebody will say, this is going to work great with my brown carpet and my black Noguchi table. They order it, they get it, and it's got a whole bunch of little brown dots and no black, and they return it. So they have more than a 30% return rate on all their pony skin. And so basically they told me, you know, you can have no variation because the market doesn't want any variation. Which is just interesting, because I think the mantra around design and architecture schools is variety, variety, variety. But more and more I find out there's no hard and fast rule about that. So anyway, these patterns originally were all unique. And I'll talk about it later, but how you design a thing which has endless variation is really a design problem. It's not happy accidents, which is more or less how most people work with that is, let's set a couple variables, cross our fingers, and hope something works out for the best, and we'll pick the best thing out of 50,000, where this problem was really, how do I design 50,000 patterns, each one of which is as good as every other one, which is just a totally different mentality of design. Okay, these are a few of the, we've got like 6 colors of them. Is what we ended up with in terms of variation. But you can see it's an upholstered top with 3 different kinds of foam and a hard fiberglass base. So anyway, the issue of color and pattern for me, there was this project that's not going to get built for a visitor center in Costa Rica, where it was built in white. Everybody in the office loved it in white. I said that I had this idea from all of these projects about gradiating the color from the green in the jungle to this kind of hot flower. And I, was bringing my work home, talking to Sylvia, my wife, about it. So I said, look, you got to come by the office and take a look at this thing. I'm really excited about how it's looking, but everybody in the office thinks I'm crazy. And she walked in and just said, that is the ugliest building in the world. And so I've spent the last couple of years trying to theorize why it's the most beautiful building in the world. But the idea of gradient, I mean, this was the most shocking because it gradiates between contrasting colors. But the idea of pattern, which accentuates curvature, and gradation, which accentuates curvature, is, this is a barbecue grill for Alessi. So this is the Visionaire case. So this is the hinge is here. So when you open it up, it rests open on that hinge, and when you close, it bites together. Oop, doesn't want to go away. Okay, the other thing, you know, and it's related to this color issue, is there's something very unique about Southern California right now. I think it's probably unique about Boston, except for that last component here, the entertainment complex. But in places, basically around universities, what you find is that there's a lot of very, very high-tech construction going on around the military complex. There's a lot of research that's funded and feeding into that from universities where you can find out about this stuff very early on. And what's interesting about LA is the entertainment industry is tapping into that, mostly for the story, but also partially for the construction. So, you know, the fact that there are, 18 car studios, plus all the military stuff, plus the university, means there's a lot of stuff that we can try to get our hands on. So for this Alessi coffee and tea set, we used superformed titanium, which is basically, we prototyped it all with plastics, which is vacuum-formed plastics in the office. But the idea is you just take 2 molds in graphite, put a pillow of titanium between these molds, put it in an oven. They pump out and burn out all the oxygen. So the oven is a vacuum. They heat it to about 1,000 degrees till the titanium gets soft. And then they put some argon gas in between the sheets of titanium and ignite it, and it drives the soft titanium into the tools, into the graphite tools. But what it gives you is this incredible resolution on the surface. So, like, this is much higher resolution than the plastic, and it's titanium. Super strong, very light. And what's great about titanium is when you color it, you use a process that's like anodizing. So you put it in you pickle it with voltage. So when we built these, we built a jig for all the parts, and we would dip the parts in this salt bath, and then the operator would turn the voltage from, whatever, 800 hertz to 1600 hertz or something, and it would go through a predefined spectrum, but it went through this green into gold and then into this kind of burgundy. So the color is a gradient color, but it really, makes the surfaces pop. And then you can see it here. We designed a reversible tray, so when the tray is standing in one direction, these stand up, so that they hold liquid. Those are their tops. And then when you're done with it, you flip the tray over, and you can display this thing like an open flower with these things all on their backs. But so you really see the gradation on the inside of them. Okay, which brings me to plastics. And back into architecture, curiously enough. Like in industrial design, I'm working more with metal, and in architecture, more with plastics. And these are the 4 methods for shaping plastics. And I think the idea that plastic is the architectural material that has no qualities and has no shape and has to take on the shape of other things is really incorrect. I think these processes for making plastics at scale really have their own assumptions, as a kind of medium for design and construction. Okay, so for the Intricacy show that a lot of Harvard faculty were in, down at the ICA, we got the grant with the idea that it was going to be my show, but I wanted to curate a show. But I had to do something. So I did these ceiling lights, which we cut the molds in foam and found a local surfboard and boat repair guy in our neighborhood who laid up the fiberglass. And laid up just means that you make a mold, somebody puts cloth or chopped fiber down and builds it up layer by layer. So for the Bloom House, which is under construction in Los Angeles now, the whole ceiling becomes a giant luminous light fixture. It's like 65 feet long, and it's all laid up in fiberglass, and has several hundred dynamically controllable lights in it. A lot of the wall surfaces of the house are made in thermoformed corian, and some of it is plaster, but in the plan of the house you can see that it's a kind of a loft space. It's like a one-room house, but folding off the walls are things like offices. This is a powder room. The fireplace folds off the wall. As you saw, this light folds out of the ceiling. So it's a crisp, loft-like building, but all of the interior rooms are these pocketed kind of nooks that fold out from the wall surfaces. And this is being done in CNC cut honeycomb panels from Panelite. This is a plaster wall. This is formed concrete where the fireplace comes out of the wall. The ceiling light is all fiberglass, and then the whole kitchen is formed in corian. Then upstairs there's a kind of spine wall that runs through the whole house that's also all corian, formed corian on the second level. So you can see in section that a lot of this stuff is folding out of the ceilings. And you can see the elevations of the bathrooms that I'll show you. Also, the windows and fenestration is all, I found out that Pella, believe it or not, could make these windows with all their Pella guarantees, because you just take what they call a cathedral window and flip the sill down. You can even get we're getting this one is operable. One on the other side is operable. So these are all wood windows with a kind of stainless steel reglet that flashes the whole thing out. But so the windows all follow this logic of these kind of undulating curves. The kind of elements I'll show you, and that's just showing those windows. The bathrooms are all built in thermoform corian, where we build kind of composite wood and foam molds and heat the corian up over almost a day to get it soft, and then slump it into these forms. For the acrylic tanks in Singapore, for a project with Frank, it's the same deal. They're just 1 meter thick sheets of acrylic, and you heat them up for 27 days, and then you thermoform those onto stainless steel molds. But it's all basically the same idea. You've got to make a form that can be slumped into a shape which you can pull the object back out of, so it doesn't have die lock. So the kinds of constraints of that shape, pretty straightforward. That's the second bathroom, master bedroom. This is a table in the kitchen. That's the kitchen island. So all of the components that we could do in a kind of like a stone-like material that were wet elements, we're doing in this thermoform corian. This is that Panelite wall. That's just plaster. And this hallway wall is all plaster. But all these surfaces are draped or thermoformed, and that's really where the logic comes in, other than the skylight, which folds back on itself because it's laid up. Okay, so to talk a little bit about the curvatures and logic of these kinds of shapes, the principles, I think, are that instead of thinking about an object that gets deformed, you really have to think about a sequence of objects in position. So it's not really about curved shapes even so much as it's about the repetition and rhythm of elements in space, where they're no longer module, they're no longer on a grid, but they follow a different logic, which is really a logic of calculus, meaning that it's continuity and subdivision. So you can infinitesimally subdivide elements into finer and finer components. But as you do that, they'll always have a logic of position, which is of a continuous flow or rhythm. And that leads to this idea of intricacy. So instead of thinking of a grid that subdivides, or even a more antiquated idea, a dimension that is fractionally divided. I mean, like architects before Palladio, who would always think of something being 2/3 the scale, a length that's 2/3 the width. And instead of thinking of a module where you subdivide a module digitally, instead you think of something that's more intricate, something that's infinitesimally subdivided. The other side of that logic of calculus is a logic of partial differential equations, which literally in mathematical terms is just running the whole system the other direction. So instead of having a continuous calculation where you try to find subdivisions infinitesimally, you instead start with a module which is fluid and work from the component out. So the partial differential equation model, which for people that are using computer modeling tools is the logic of subdivision surfaces and the logic of smooth polygons, works in the other direction, which is creating families of form, or things which are provisionally grouped into sets. So these are just some images of the embryological house, which is the first thing I ever did that had that logic of this has the same number of panels for each one. It's mathematically identical, but they produced a kind of family relationship of similarity. So the kind of sameness in their construction, that they all came from the same number of panels, from the same number of molds, had the same surface area more or less, but each one was unique, was looking for this kind of family relationship of elements. The logic of intricacy can be, let's say, non-modular. It can also be modular, but based on changes in position, which is what Nadir and Monica's work, I think, is very much about. So as an example, with the Korean church, each one of these elements is the same. It comes from the same family. They have the same logic of connection. Every tectonic piece is unique, but they set up a rhythm and a pattern which is based on this family relationship and rhythm. So it's, the biggest idea is that it's not based on a module that you make variations on, but it's based on a kind of holistic set, each component of which is infinitesimally changing in a rhythm. So in terms of tectonics and pattern, I think that's the logic of calculus in action. The end result of that is probably a parametric sensibility. Now, I personally find the parametric sensibility a little suspect, because I think it continues that method from the early 90s where everybody was an amateur using computer models, and so everybody was plugging in variables and just getting garbage out and picking the best piece of garbage, which I was like the biggest advocate for a long time. But I find it very difficult to come up with a parametric approach without already having a design intention in the end. So I'm not a big advocate for bottom-up design, because I like to know what the bottom is before I start setting up relationships. But so this is an example of how we've used parametric modeling in the office. In this facade for housing project in the Belmer, each one of these vertical trusses, which holds escalators, is unique. And as we were modeling these things based on lifting the escalators and clipping them to the side of the building, it was just getting ugly. Like, I don't know how else to say it, except I wasn't happy with the transitions that these elements were making one to another, because they were all very discrete decisions. So we'd locate an escalator where the escalator would stop, we'd get this abrupt transition. So we built a modeling tool along with Bob Aish from Bentley in generative components, where we set all of the construction elements of these vertical upstanding trusses, which were basically two tubes that roll in one plane, another tube which is constant, all the triangulated bracing to support them, and then these clips that hold stainless steel mesh cladding. And we set all of those things in hierarchical relationships one to another, and we set some kind of more global things, just basically setting the existing floor levels, and then setting clearances we needed for escalators. And we built that as a modeling tool. So each one of these red dots are where an escalator intersects with the truss. This is kind of how we built the system. We set a vertical center line of structure with points, and off of those points we had these spreaders, which were always in the same plane, and we arrayed that floor by floor up the building. We then located control points for where the escalators would intersect it, and with those two sets of relationships, we could array all the components for the curved tubes. Then what we did is we set it up so that every point would look at 7 trusses to the right and modify themselves and temper themselves to the 7 neighbors. And then they would work their way back in the other direction and look at all 7 neighbors to the left. So it was like a kind of tempered scale where you'd get an abrupt transition, but that abrupt transition would get smoothed over 14 elements. So it eliminated these kinds of abrupt transitions, and it put what ended up to be, I think, over 10 million pieces of construction component, like not including bolted connections, but all of the trusses and each component the truss was made out of was calculated in a single equation. So there was basically one modeling moment where every time you would move any element on the facade, it would ripple through and recalculate the whole facade. And the building's almost 1 kilometer long, so it would ripple through all of these different elements. But anyway, for me, that's a parametric tool, but it was a parametric tool that came into the process at design development, let's say. It wasn't something we generated the design with. I think the second scale of issue, when you start to work that way, is making up these kinds of families. And what I've found is this is an intelligence which is unique to architecture. So I've used this example over the years, but way back when with Sanford Quinter, I forget who else went up, Johan Bethem, we all got invited by Volvo to come up because Volvo said, look, we've got these factories that all of the machines are on wheels and reconfigurable. We have a different model of car coming out one after another. They believe they had the capacity to make every Volvo a little bit different. The only problem they had were their engineers, first of all, and their designers, second of all. And what they said is, we think sometime in the near future, people are going to go to a Volvo dealership and they're going to talk to a Volvo architect because they don't want to go online and design their own car. They want to go talk to somebody that knows what the issues are. They're going to tell them what they need. The architect's going to interpret that into a document. They're going to send it to the factory, and they're going to get a car which is unique for them, just like they would do with the building. So they said, so we're bringing the architects in because we know this is how you guys work every day. And we all kind of looked at each other like, wow, these guys have more faith in us. Like, we're running around looking for some kind of giant 3D printer so we can make a big lumpy building. These people understand architecture better than we do because they said architecture is about assembling big numbers of components in a cohesive, holistic way, and that's what you do. And it was a real revelation for me to have somebody tell me back what architects were supposed to be doing. So It was at that point that I started thinking about this problem of families of form, which, you talk about Core, Mies, whoever. Architects need a signature, so they need coherence. They automatically are dealing with this issue of variegated families of elements. And I think that's why industrial designers are looking to architects every once in a while, like companies like Alessi and Vitra. Okay, so the first way you can do this is with identical components, and you just vary their position. And I would just show, this was the kind of research as United Architects that we did, and came up with this idea that you could pinwheel identical floor plates around cores to get a variegated profile where every single floor of the building was absolutely identical. Because in New York real estate, everybody knows you got to have 52 to 56 feet from the perimeter of your wall to your core, or it's unleasable space. So we tried to take all those requirements of repetitive identical floors and accept those, but through position in space, generate something which was not repetitive. Same thing for the competition we did for the European Central Bank. We did it like a big piece of money. I got to blame Ben. This was all Ben's idea, the big coin. But what we did is located 3 cores, and around each one of those cores, we pinwheeled an identical floor plate to produce this spherical profile. And between all those elements, we had these kind of amazing void spaces, and then we captured these kind of second skin sky lobbies through them. But so every floor in here is exactly the same. It's just pinwheeling off of a core differently to produce this globally changed profile. But locally, it's totally repetitive. The other extreme is thinking about designing families. So, these are the first studies for the Alessi teapots, where you can see, and this came right after the housing project facade. So we designed, I think, 8 curves, which were mutually sympathetic. And each pot was made out of 3 curves with shared parting curves. And so you can see we just did an equation and designed the thing in Microsoft Excel, where it would generate all these loft curves, and we would bring it into Maya and loft them all up. And we had hundreds of thousands of coffee pots, all of which were equally beautiful and equally ergonomic. But I'm telling you that without ever having seen all of them and compared them against each other. It's just that we designed the whole collection. We weren't designing a bunch to pick one. We were designing the whole family. The same principle holds true for this, it's 28-unit housing block in Valencia, Spain, that we're just finishing up, where every apartment has constant components and variable components. And what's variable is this void that cuts between the kind of back-to-back apartments. And you'll see it in the plan. Well, this is a section through those voids. So this is kind of my Michael Graves Princeton training, coming back to haunt me with the poché. But you can see every one of these apartments is not only slightly different in its interior, but every one of them has a unique window, because these voids and the wrapper that connects the voids is all undulating through the block. And this is 6 stories high. That's the facade, but you're looking at it end on. So there are these voids that run there and there. And each one of these panels that this company Arcelor is making in France, each one of these panels is going to be one of 9 colors of silver. There's one white and one black. But so it'll be very much like a kind of jewel or a geode, where they'll change their shape, or change their reflectivity with the shape. Okay, you get the idea. That's just with 4 different kinds of metal, but that's the principle of it. Okay, so I think the other thing, if you're going to design one of these variable families is you've got to engage the generic in a way that doesn't think of it as something that's totally banal or everyday. So for me, the generic in the sense of, say, William Bateson in the 19th century, he invented the term generic, and when he said generic, it was the yet to be specified. So he was talking about generic forms which change due to genetic information, but the generic was the thing which was common but not complete. So for almost every project, we start out with a generic primitive, often just a sphere. But so this is a drawing by Bateson. He was a teratologist, so he tried to find rules by studying the monsters rather than studying the ideals. And what he found, which is still called Bateson's rule, is that in digits, in everything from insects to humans, when you get a mutation, it usually follows this logic of mirror symmetry. So if you're going to have a mutation at your thumb, what you'll usually get is another little thumb opposing it, or you'll get 4 fingers opposing it where the thumb should be. And Bateson's idea about this was that growth proceeded by 2 methods. Generic growth was just simple mirroring and symmetry, and specialized growth was genetic, where some information intervened to change it. So things would just proliferate by symmetry, and when they would come into contact with genetics, they would do something specific. So this kind of real early project of mine, Cardiff Bay Opera House, was all this logic of mirror symmetry and growth, where things would mirror off each other. It was very inspired by Peter Eisenman's biocentrum I worked on. But so back to product stuff, I was asked by Alberto Alessi to design flatware. And he said, look, just make me a beautiful spoon and bring me the spoon and we'll do the rest. Like, that's how every designer always works, is what he said. And I was totally offended by that. And so, so I decided to come up with a way where there would be no ideal quality to the spoon, because I didn't want the fork to be a bad version of a spoon or whatever, a bastard spoon. So I came up with this primitive, which was whatever, a piece of flatware, and then started to give it traits, just like you would give an animal traits. So there were forkish traits, knife-ish traits, spoonish traits, and we could start to mingle these things and start to bring different characters out of them. And combined with that, we came up with a kind of articulation of like tongs or tines or all of the parts of flatware, which is like a tube, with these webs, like so for the knife blade or the spoon, whatever. So out of that, you know, we started mutating and designing these things. This clicker doesn't want to go fast enough. But so we came up with a lot of just kind of free variations. Then we started to go back and look at function and try to revive all these things like pickle forks and mustard spoons and cream chip beef serving forks and bacon forks and fish knives and, you know, you name it. So, and all these things had to do with kind of social codes, like your salad fork is supposed to have 3 tines and your table fork is supposed to have 4. But also things like pastry forks are supposed to be more like a spoon for soft cakes, but they're supposed to be able to, you know, drip sauces off of them. And, you know, there's all kinds of, you know, functional protocols for these things. And so this is about 1/3 of them. But you can see that it's not like we just took a spoon and changed the scale, or took a fork and changed the scale. We started to add all these traits, you know, ladle traits, fruit spoon traits, you know, slotted pancake spatula traits. You know, so every one of these things has its own traits, but again, they're all part of the same family. So there's like almost 50 of these things that we made. And these are all the steel and bronze versions of them. Okay. We're almost there. like 15 more minutes. To talk a little bit, and it's related to this logic of structure in this flatware, to think about the relationship between surface and structure. A few years ago, well, actually, it's maybe worth a little bit of a digression. The first time I got a piece of animation software, I remember I had to, I was a kid, I got together all the money I could. I bought a Silicon Graphics workstation used from Grumman Aerospace. It took forever to get delivered. I got borrowed software from Wavefront, an Alias at the time. I installed it. My plan was to do this competition for the Port Authority Gateway. And it turned out I got everything installed and set up 3 days before the competition was due. So, and I had no idea how to, I was pretty good at using software, but I never used animation software. So, and this is more of a cautionary tale, let's say. So, what I did is mapped all of the context. So I said, well, cars go 35 miles an hour, the buses are going 15 miles an hour, people are walking at 3 miles an hour. Mapped the whole context in 3 dimensions. I obviously knew what I was going for. I used these particle tools and dropped them in the context, and they made a pattern. Okay, so let's say day 1. Day 2, I spend all my time snapping lines through all these particles and making these crazy self-intersecting looping curves. I took this over to my friends at Burrow Happold, and they said, what's funny is because these are all bouncing balls, they're all catenary and they're all inherently structural. So I said, oh, well, so now I'm an engineer. And then I tried to make an envelope out of those things, which was impossible. So I chopped it up into the smallest pieces that I could get to surface and surfaced them all with tents. Okay, so it was a 3-day panic amateur encounter with some very sophisticated modeling technology. Now, everything I've done for the last 7 years has been solving all those problems architecturally and theorizing them. So one of the biggest things was, what do you do with a curve that's intersecting itself? And for years, we would model surfaces, and we would offset the thickness. I hope this makes sense to a few people in the audience anyway. We would offset the thickness, and we would always get these funny, clipped versions of the surface when we would offset it. And I found out it's because all software has this stuff called curve loop cutting, so that you don't get things that invaginate or that fold through themselves. So here's an example of what happens when you add material thickness to a calculus-based curve that has no real dimension, which is, I don't have the drawing with the points, but to get this curve with this pucker, what it means is there's a series of snap points along this side of the curve, and then all of a sudden you might have 3 or 4 of them that jump on this side of the curve, and then they jump back over here again. Now when you add thickness, let's say 14 inches of thickness to that, what it does is it looks at the position of this line perpendicular to this spline, what's called a normal, and it moves it 14 inches. So it moves everything 14 inches this way. But when it gets over here, it moves it 14 inches in the other direction. So what happens eventually is you get these loops that pass through themselves. And so the software assumes these are bad, so it clips them off. But what happens is if you're trying to position mullions or panels or something, you're clicking along panel, 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 and then all of a sudden, this stuff just disappeared. And I could never figure out what it was until I learned to turn off the curve loop cutting function to keep these things, which industrial designers call blebs. Don't know why they're called blebs. But anyway, we decided for this I-beam competition to use the skin as a spatial body where in these folds we would be able to cantilever rooms out into the street and would be able to fold rooms back into the building. So this is a little detail of that, and this is a kind of structural section of the building. But so this is just to say that for a while I've been playing around with this idea that surfaces could contain volume in these self-intersecting loops, which come about by adding surface thickness. So this is a model. Anyway, we use this for the St. Gallen Museum expansion entry here, but what's important is we're using it in our house in Venice Beach. So the way the house was masked, and it's in the end kind of all Zaha Hadid's fault. We have this great bungalow, Sears house, built in a factory, put on a train, shipped to our site. It's everything that I should believe in. And so we decided to expand our house by cantilevering a volume over the existing bungalow. Zaha came by about a year ago, looked at the models, said, I got to see this stupid house of yours, Greg. Came to the house, said, wow, this is the best craftsman house I've ever seen. Knock it down, you know. So the partie of the house maintains this kind of cantilevered bar over a mass, except it's all one thing. And it's a pie-shaped site. The roof is all just because we wanted to maximize the height, so we have to have a 1-in-6 pitch. But for me, what I wanted to do is use the kind of rolled steel logic of that I-beam to produce the kind of formal qualities to the house. And so with the engineer Klaus Bollinger, who I teach with in Vienna, we started to look at what scale the structure would need to be and how to design a truss, like the Bollinger-Lynn truss, that would hold up the two shear walls of this triangular site. So what we did to keep it light, to keep it thin, is eliminate the idea of a beam and a column, but to use a single 500 and some foot long tube that rolls all the way through the house and back, and which folds on itself to give it its structure. To do it, it's easier, therefore cheaper, to make all of the sections radial. So this is all modeled in Digital Project, the Gary technology software. But we set constraints like, doesn't want to go backwards. We set constraints like center line of structure for the slab and snapped all these elements together and constrained them so that we could have a modeling tool that would always give us radial sections and would give us the kind of continuity we needed in the tubes. You can see this is a real early one. You can see how these are all snaking in and out of each other, which is in the end what gives it its structural stability, because these are all welded together. Okay, so there's one line of that looped steel here. There's one line of it there. And then in between, we designed both voids and solids that would cut through the house. So this is a kind of real early version, but you can see this is a courtyard and a courtyard. These are the loops. I don't know if this is making sense, but these align to each face of the structure and fold through themselves. So what we're doing because of the climate is there's a living space down here that's enclosed, but 2/3 of the house is this semi-covered outdoor courtyard with these voids that punch through it. This facade of the house faces directly south, so that in the wintertime we get a lot of low sun, so the whole courtyard will be in sunlight in the winter. In the summer, we'll only get light where those courtyards are, which is exactly what you want in Southern California. So it goes bathroom, bedroom, 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 and in between each bedroom is either a solid, which becomes bathrooms here, or a void, which are these courtyards. So these are the, kind of, when you're your own client, I don't know what to call it, but let's say the schematic design of the status of the plans. So this is all pivot doors, and so this is like one big living room out here. This is one of the courtyards, that's one of the courtyards, and then these are two solids. This is upstairs where you get the bedrooms, bedroom, bathroom, all with these voids. Like the thing in Valencia, I showed you the public housing project, just smaller. And And then the north wall is all channel glass, which is this kind of aquarium-like glass. So you'll see the structure ghosted behind the glass. And then where there are operable windows, you'll see the structure, popping through more visibly. Then as we move inside, again, the kind of Asian pop evil cuteness, which also has a lot to do with my wife Sylvia. We started to move it really into plastics. So, and she needed an office. So we started to play with some people I know in Austria that make all the ski lift covers in acrylic. And they CNC the acrylic. So for the facades, unfortunately we can't break this beam. But for the facades, we've got bubbled acrylic that's bonded all together into a single sheet. And then for the interior walls, I kind of reinvented the brick as a plastic brick. That's why at the beginning of the lecture I had this thing like the brick that decided it wanted to be plastic. So the interior walls, these red ones, are built out of a standard plastic brick, which is custom trimmed so that it's self-supporting and it stacks up. And that's the only part of the house we've built so far, but I'll show you some images of it. Okay, so this is this, this is this custom brick, and this is like a commercially available product for hotel lobbies and apartments, gardens, stuff like that. But I started off by designing the brick at a scale that you could assemble it without any mortar. So each one of these bricks, I think we got a picture of one, yeah. So this is one of those plastic bricks. It's rotomolded, which means we just made a very inexpensive tool. We can pop one of these out every 15 minutes. They cost about $25 a piece to make. And we take each one of these bricks and set it on a jig, and we can trim whatever part of it out we want. So, and it's designed the way it is with these kind of noses and bumps so that it can make grotto-like spaces. So we array it. You can see there's an X, Y, and Z surface that we model this with, and as we tug on the surfaces, it rotates the bricks in that area in the X, Y, and Z coordinates. Then we intersect all the bricks against each other, and we find the lines of Boolean intersection. We set these things on a jig, and with a CNC machine, we cut out all the scrap, and these things interlock and stack up into a self-supporting wall. So this is it at the MoCA show. This is about 150 bricks. And then these are pictures of us driving it around LA, visiting all its friends. Bonaventure, Cinerama Dome, Pacific Design Center, Beverly Center. Anyway, it's better outdoors than indoors. Neutra. Okay, but anyway, it's a new take on a mortarless brick. And also, you can't believe how this thing was bouncing around on the back of a flatbed. It's super, super strong. Okay, so finally the whole Los Angeles media thing, and then we're done. This is a planet we designed for the film Divide. Which, I'm not going to go into the whole script, but some friends asked if we would design 3 planets. I think this is Divide. That's Asia, and this is North America. But anyway, the brief was to design this kind of porous Central Park scale envelope. But that kind of interaction with the film industry, with television, this is the thing we did with Imaginary Forces. That kind of access is now for the first time kind of getting into the architecture. Like the thing I showed you in Singapore is the most extreme and exciting version. This is a little bit more pedestrian, but similar idea. This is it's a really tiny little project, but it's super great, a really amazing location. This is the Los Angeles County Museum of Art. This is the existing complex of the building here. This is the May Company building, if you know it. And then this whole new entry sequence by Renzo Piano is going to open in a few months. And this is the Broad Art Center, which is a 4-story gallery building by Renzo Piano. So they're reorganizing the whole thing into this forecourt right here. Well, a very saintly and savvy developer named Wayne Ratkovich found this 32-story tower vacant, believe it or not, right across the street, bought the tower. It has these 2 satellite pavilions, and it was designed by Pereira, the same architect that designed this building when LACMA was first built. So he wanted to make an address on Wilshire Boulevard by building a restaurant and cafe right across the street from LACMA and redesigning the whole landscape and garden and making a kind of gateway into his building. And so this is all with Nord Erickson, who's a landscape architect. So we started the project by looking at all the kind of Los Angeles Avenue Boulevard stuff. In LA, it has a very different method of address because it's all automotive boulevards. So you get these things like Randy's Donuts, the Binoculars, Cinerama Dome, all these things which make canopies and figurative objects on the boulevard. So we tried to do a similar thing with the forecourt. And what we did is we took a trellis, like a covered trellis, that extends over half of the site and makes a gateway into the entry into the buildings. And the columns of that trellis get fatter and fatter and fatter and basically bubble together to make a restaurant pavilion. So these are just, the ceiling plan. It's pretty faint. But here you can see that trellis. The tenant, we don't know who it is yet, which is very scary. I mean, for all I know, this could end up being a Jamba Juice. We hope it doesn't go that way, but they pay the most. So we tried to put all the architecture above 8.5 feet. So the whole character of the space is all in these complex vaulted ceilings. And basically, it doesn't have a major address on Wilshire in terms of its interiors. But so you can see it's very Baroque in the sense that it invests most of the architecture in the ceilings. We also, the lobby of the existing tower is a kind of double height space, and we align it with the cornice of that and try to extend that lobby out to the street. And the place where the media comes into it is in this trellis. Here you can see, similar to the house, my house that I showed you, say 3 months out of the year, you want to sit outside, but you want to be in total shade. 6 months of the year, you want to sit outside and be in the sun. Then there's probably another 2 or 3 months you don't want to be outside in Los Angeles. So we designed this trellis with real specific orientation to the sun so that December 21st, you can see under the trellis, you get total sun, like no shadow at all except for the 1/2-inch thickness of the aluminum blades of the trellis. Then June 21st, you get total shade. So they're oriented for the sun angles so that lets the light through in the winter, keeps it out in the summer, and then at the equinoxes, it's somewhere in between. So you can see you get partial shade. So a lot of this thing is about sitting outside and being in this park, and there's a couple hundred seats outdoors from the restaurant. Then what we do is we take that trellis and at night, use it to produce kind of like a subtle spectacle on Wilshire. So each one of these bays of the trellis has a dynamically addressable LED light source. And that's where we went back to imaginary forces. And I'll show you, sorry. Like these, they did a series of studies of the movement of the light through the trellis and what kind of effect it could have on Wilshire. Maybe if you get out of PowerPoint and go to one of these movies. Okay, so, oop, but I think you'll get the idea. I mean, for me, you know, there's really no need for this thing to be a sign or to have a kind of television video quality image. It's more about producing an atmosphere and a mood that complements LACMA across the street and also can compete with the traffic and lighting of Wilshire Boulevard. Well, it's not that important. If you can kill this if you want to go back to the PowerPoint. You'll get the idea from the stills, I think. Okay, so anyway, they set up a whole pattern of how it moves. It's too bad you can't see the movement, but it's more or less an atmospheric movement. And they did studies that went from clouds, like the speed of clouds moving on the site, to headlights, you know, kind of glancing by the site, to the scale of people walking around. But you know, you can produce a whole set of kind of dynamic theatrical effects in this trellis at night that'll really activate Wilshire and give this place some identity. I think the only other thing that's kind of significant about this, you know, is also the, you know, I'm only saying this because I know it's a discussion around Harvard with Farshid, and the whole issue of metaphor and when things start to look like things. You know, the tree columns, you know, I never thought of as trees. I was basically just, you know, this sits on a big parking garage, so we're lining these up on the parking garage and branching them up to hold this trellis where it gets deeper. But as they started to go towards trees and this skin, we decided to do this kind of diagonal, like fishnet paneling. It was important that these things not look like literal trees and that we take the two away from each other a little bit. So you can see, you know, the skinning and faceting of these elements, you know, is very much finer and of a different nature than the skinning and faceting of these. So this play between the columns turning into the volume of the building and the smooth vaulting of the interior of the spaces versus the kind of stick articulation of the columns is something we're trying to play with to keep it close but not let it go too metaphorical, which, you know, is another kind of preoccupation, let's say. All right, so thanks for being patient. That's it. Yeah, does anybody have questions? Spun.
I wanted to ask you, on your evolution since the time of animate form, in which you had a pretty programmatic discourse on architecture. It seems, or at least this is, that notions such as pleasure, mood, an almost gustative relation to form, pretty struck by the relation to pastry in terms of color, etc., has replaced that. So my question would be, at that stage, what do you consider as still programmatic, or trying to be exemplary, or launching a program in what you're doing today? And how would it be different from what you used to do?
Well, it's not like any of this was, that I was anticipating any of this. It's more, I'm a victim of my circumstances. But I do think that when something like the modeling tools, became available, it immediately turned me into an amateur in the sense that there weren't people using those tools that I could look at for expertise. And so I think, I know my first response was more experimenting with the tool and then justifying those experiments with what seemed to be pseudoscientific, quantitative information. As I got to be more proficient in the tools, I was also more proficient in accommodating the quantitative stuff, and at the same time didn't feel like I needed to justify the forms with the quantitative information anymore. Only because the forms take on, basically when they go in the world, I can't be there all the time to say, like, this was going 15 miles an hour and this is going 3 miles an hour, and that's why it's this shape. So, and I think this is a general problem my whole generation has different attitudes towards. But for me, I take a lot of pleasure in when those things go in the world and come back. And I like to play with that audience and the reception and try to anticipate it in a design, let's say. So that's why, but okay, let me just say the good thing about having lived through that is in the office and in my teaching in Vienna and stuff, I always tell the students never go off package, which is an automobile term. But when automobile designers design, they get what's called the package, which is the wheelbase, the engine position, the number of seats, all of the kind of programmatic requirements are totally fixed, and they're not allowed to touch those things. And they're not just stylists, but basically they're styling, or some of them even still call themselves aerodynamicists, but they're working off a package that they don't depart from, and if they depart from it, it's like a big deal. I mean, you call the board and you say, look, we're going with a 6-seat SUV instead of a 4-seat sedan, and it's a big deal, bring everybody in, and so otherwise you stay on the package. I always am on package in every phase of the design. So that experience of quantitative justification means that it's kind of part of my habit to start with that quantitative stuff totally locked down and then start to play with it. So, we never find ourselves making a shape and stuffing it with program, or making a shape and trying to figure out what to do with it. And it's, in fact, why the collaboration with Frank could go pretty smoothly given all our differences, because he works with blocks and skins them. I work with volumes in a computer, and that kind of common, like, get the program modeled first and model off the program was a thing we both really had in common. So yeah, I try to be more responsible to the reception of these things, not to their engineering, but I do always have that in the back of my head, which I think is, gives me more freedom in a funny way. No, it's very true that it doesn't, because I don't start with it, I am always bumping into it. It's, I'm not really that, fussed by it or whatever. Like, I don't mind when it comes in, but I don't really start with it that way. Like, that's why when we did the thing on Wilshire was a kind of little mini competition, and it was a mini competition between 3 architects, but also a mini competition between 3 landscape architects. We never met. And when the landscape architect was picked, and I was picked, they put us in the room, the landscape architect said, wow, cool, trees, it's a bunch of trees. And I'd never seen it, and I suddenly thought, oh, well, A, this will let us have a rapport, but, B, I don't want it to just be that. I don't want it to stop there. I think it's the only problem probably for me with metaphors is it tends to shut certain avenues of development down sometimes.
You just said that you're experimenting with new tools. And the question is, where do you draw the line between you experimenting with new tools versus new tools experimenting with you?
Well, that was, I jokingly said a long time ago when I started teaching at the ETH, I said, look, the Americans all say, what does a tool want to do to us? The Europeans all tell me what they want the tool to do. And I'm more on the side of the kind of technocrat, where I'm more interested in what the tool does initially than I am in what I want to do. So when I go for new tools, I'm usually going because they do a specific thing. But the tools never do anything. It's like oil paint. Like, the oil paint isn't doing anything. You're painting with oil paint, which is different than painting with acrylic, but the oil paint's an inert medium. It has no vital force, no expressive force. The expressive force comes out of what you do with it as a medium. And for me, that's like a significant shift. 10 years ago, everybody said, the tools have an agenda. Like, the tools, there's a right way and a wrong way the tools want to be used, which is right. But the tools are just, they're a medium. It's like a new expressive medium that has its own characteristics, and if you use the medium incorrectly, maybe you break through and do a new mode of expression, or maybe you don't. But for me, it's really these digital technologies. It's much more of a design medium than it is like a, some new intelligence. It's also, they're really converging. I mean, next couple years, it's amazing how, basically Autodesk is consolidating all the stuff it's interested in, smashing all the stuff it's not interested in, and covering as many disciplines as possible. And what's kind of curious is architecture is still the biggest user of all that stuff. So it's not like this is all coming from somewhere else. It's always been done by architects, for architects, even Maya, it sidelined into other fields, but they still sell tons of those licenses to architects. So I was talking to the 3 big software companies were all running through my office last week because something's up. And they're about to reconsolidate again like they did a few years ago. But they were saying there's 140,000 users of CAD software and architecture. There's just like 10,000 or something like that in Hollywood and industrial design all put together. So we're like the big industry for this stuff. And it's designed as for our medium, more or less. So to distance ourselves from it, to say it's going to do something to us, is I'm a little suspicious of it. I mean, the example, I didn't show the Port Authority, but the example I gave of a bottom-up process that produced these self-intersecting curves, that was like a happy accident. And so I did that happy accident, say, 10 times. When you start doing happy accidents 10 times, they're not happy accidents anymore. It's like a rigorous system. So for me, bottom-up design is very relevant for certain kinds of tasks. I'm not convinced it's relevant for architecture. What I see happening in bottom-up is happy accidents, which is just a very different thing. But if I'm hearing someone explaining their design process as a bottom-up process, what they're really talking about is setting the stage for, you know, unforeseen happy accidents to happen. You know, it's just the irony is after 10 years you can predict every one of those happy accidents, so why bother doing it that way? And I just find the discourse of bottom-up design tends to support a level of amateurism in modeling and a lack of rigor in modeling that I just, you know, basically I have an aesthetic problem with it and a theoretical problem with the lack of rigor to it. You know, but as new tools come in, you have to experiment with them that way. But it's just, I think most of those experiments have already been done. And we're just in a different mode now of, you know, both some amount of rigor and some amount of expression, but probably not that kind of moment of discovery of the new tool. It's also personally, I know it's like the worst time to be around. You know, I feel cursed by the fact that these technologies came in while I'm a young architect. It's like nothing ever that good ever gets done when the stuff first shows up. You know, the masterpieces always get done a generation or two later. So I'm in like a big rush to get into that mode and get out of the childish playing around with the tools mode. Honestly. Thanks.